Hey, good morning, good afternoon, good evening, wherever you are. Thanks for joining this AIOG webinar series. I hope everyone at your end, including you, are safe. So we are missing our AIOG face-to-face events due to COVID-19. We are confident. So we are confident we'll be back very soon. Meanwhile, we are planning to run a weekly webinar, especially on Wednesdays, starting from afternoon or evening, depending on the speaker zone. I think most of the speakers are coming from US zone. So let's keep your times available. We have received a massive response on this webinar. Again, we are providing a preference to all the registered all the registered people first. And also we thought like, let's give a live webinar and a YouTube channel. Only difference between the registered and non-registered people. So YouTube live will be live. After that, we will provide the recorded video to all the registered people. And also you can ask all the questions in Zoom channel. And also we are planning to run a quiz anyway. Kanar will explain about that. One thing we always do is selfies with the speaker. Let's do that also in this webinar. We don't want to miss anything in this webinar, right? So let me unshare my screen and let me hand over to Kanar McDonald. And thanks, Kanar, for your continuous support. And we can't say anything more. Thanks for that. So I'm handing over to Kanar now.
Okay, hopefully you can all see me and you can all hear me. Sing out in the chat line if you can't. As you can see, it's welcome. It's nice to do a webinar for me at a time zone which normally suits me. Most of the webinars I do very late in the evening. So it's nice to have some people from India, similar time zone, 2.5 hours. It's 4:30 p.m. for me here. Hope you're all doing well. Let me get straight into it because we've only got an hour, and what we'll do is let me share my screen and we'll get stuck into it. Now, hopefully what you should now see is be able to see both maybe me in the corner somewhere on your own screen and also my slides. Hopefully that all works well. So by way of introduction, my name's Connor McDonald. I'm from Perth, which is on the western side. And funnily enough is, in terms of the way the world has changed, literally when I gave this similar talk only about 6 or 7 weeks ago, this was the slide I had, because the big news was the fact that there were bushfires in Australia. It was world news. It's funny how times have changed, isn't it? That doesn't get news nor. There's obviously something far more serious going on around the world. And we won't dwell on that today because we're a community. We've come here to celebrate positive things. But all I want to say is about the COVID situation is obviously focus on staying safe, focus on staying healthy, because we're a user group. And obviously user groups don't work without users. So please focus on your family, focus on your health and safety first. I would imagine India is similar to Australia in the sense that we're generally confined to indoors. So let's use that time to continue to build our communities and get some as best benefit as we can. This is how you get in touch with me. I have a blog, I have a Twitter, I have a YouTube channel. If you're not on Twitter, and I know Twitter is probably not the most popular thing in Asia as it is in the US and Europe, I'd strongly recommend you get onto Twitter, especially in these current times where a lot of the communication is being done virtually, because the big IT companies, the companies that you probably have an interest in, Oracle, Microsoft, Google, Amazon, etc., they're all US companies, and the US loves Twitter. The US use Twitter a lot. So in terms of keeping yourself educated, keeping yourself informed, keeping yourself abreast of what's going on, especially since we can't meet face to face, Twitter's a really good place to be involved. Even if you never send a tweet, just get onto Twitter, follow some people. Hopefully you'll follow me. And it's a great way of staying connected and staying informed. Our ability to utilize social media is probably more important than ever now in these current situations. As Sai said, one of the things that I really miss in coming to India, coming to those cities, that whether it's Yatra or Sangam, whatever, is the ability to actually have face-to-face and have a selfie. And I figured we can't miss out on the great selfie tradition. So what I want you to do is, here I have a picture of myself. On your own machine, make that nice full screen and take a screenshot. And then what I want you to do is take a selfie of yourself and Photoshop it into that picture. And that way, I'd like you to tweet those and just to show that we still can have a great selfie community. Call it the virtual selfie. Even call it the Velfie if you want. But yeah, just a way of let's put together some selfies, have some fun, and keep our community enjoyment together, even if we can't do real selfies. So I'll leave that on there for a few more seconds. Make it full screen on your own machine, take a screenshot, and insert yourself into that picture. And and insert whatever you want into that picture. We'll have some fun with this. This is what I do most of the time. I look after asktom.oracle.com, and a lot of people are aware of that, so we won't dwell on that. In these times of everything being virtual, I can't stress enough the benefit of hopefully getting involved in office hours. Office hours, funnily enough, is been going for a lot longer than this crisis. We started this almost 2 years ago now, and we decided that it was important to be able to provide content even for those people that can't make it to conferences. So office hours is experts inside Oracle giving up an hour of their time at least once a month. And because we have a lot of product managers in Oracle, it works out around about 3 to 4 every single week. So if you're stuck inside or you're stuck being able to communicate directly with people, this is a great way of staying informed. We've run over 300 office hour sessions in the last 2 years. There's no cost, it's free to join, and it's a great way of complementing the kind of stuff you'll be doing with your All Indian user group as well. So you've got your user group events, and we've got Oracle events as well. We're going to talk about flashback today. And when we mention flashback, this is what everyone tends to think about. The first thing they think about is, flashback is one of those things I would only ever use in an emergency. Something has gone horrifically wrong on my system. Something's gone terribly wrong, so I'd need to use some flashback technology. But the focus of this session is that it's not just for DBAs. It's not just for emergencies. I think in the way that modern applications are being built, there is actually a lot of benefit for flashback in ways that you might not have thought of. And that's what motivated me to do this webinar today. When we think about modern IT methodologies, what tends to happen now is things like what we call continuous integration, continuous deployment, test-driven development, lots of iterations of application deployments and build cycles. And we're going to talk about how flashback might be useful in this modern way of building applications. Now, when we talk about flashback, it's actually several different technologies. And there's actually 6 of them. And even though they all have the same name of flashback, they're actually implemented under the covers in some quite totally different architectures. I suspect it was probably just a marketing decision by Oracle to actually group them together as one thing, but there's actually 6 different technologies: flashback query, table, drop, database, transaction, and flashback data archive. We're going to try cover them all in the hour. We'll do our best. So let's get straight back into it. Let's straight into it, and we'll talk about flashback query first. It's always good to open a webinar to keep you interested, keep you engaged, to open up with a bit of controversy. And here's my first controversial statement for the day. Anyone that's ever used an Oracle database has always been using flashback query. Now, let me explain how I can justify that statement. Let's do some revision. Let's go back to some first basics, some principles here on the Oracle database. As you know, one of the cool things about having a database, Oracle or otherwise, is that when you do something, you don't have to actually make that change permanent. I can do an update, set some rows here on the employee table, and if I make a mistake, I can just type in rollback. And of course, the challenge there is how? How do we implement the ability to undo a transaction inside the database? And it's pretty simple. We remember stuff. That's what we do. Let's drill into a bit more detail about how we remember stuff. When you commence a transaction inside the Oracle database, in this case, I'm going to add 10% to the employee called Smith, 10% to his salary. The first thing you do before you're even allowed to change data in the Oracle database, the first thing we have to do is give you what we call a spot in the undo header. And we might give you slot number 5. So this transaction is told, yes, you have a spot reserved in the undo header and it's slot number 5. When we actually go to the blocks on the database where that employee data is stored, we can actually mark that block with that undo header. So we call it the undo block address. And so we know that I'm about to make some changes to that block. If I wanted to undo them, I would go visit undo block address number 5 in that undo header, and that's where I'd find the information to roll back the transaction. So before I even allow to change the block itself, I record the information on how to actually undo the change I'm about to make. So I'm going to add 10% to the employee called Smith. What I would store in my undo information is, before I add 10% to the row for the employee called Smith, to undo it, I would go to block 2754. I would go to row number 1 in this case, and I would change the salary back to 1,000. People often think of undo as being an entire copy of the block to undo a change. It's not. We actually store, in essence, a list of instructions. If I want to undo a 10% increase to this particular row, I would go to row number 1 in block 2754 and change the salary back to 1,000. Once I've stored that in the undo, then I'm allowed to change the block. Smith can now be updated to be a salary of $1,100. And that's how undo works. Effectively, we store the undo first, the list of instructions on how to undo it, and then we're allowed to make the actual change to the data. So when I come along and type in rollback, I can actually go look at the block itself, and it says, yes, to roll back this change, I would go to undo block address 5.1, which takes me there. And what's the list of instructions I have to follow? I would say, go to block 2754, go to row number 1, change the salary back to 1,000, and that's how I undo the transaction. And then I'm finished with that undo information. It can be discarded at any point in time. Now, at Oracle, we're fairly lazy. Why would you do work in discarding information that you might not need to discard right away? And so it'll linger around. Way back, as far back as Oracle version 4, we actually had a bit of a light bulb moment. We said, we could use this stuff for queries. And that introduced the concept of read consistency. And you may have heard the term, readers don't block writers, writers don't block readers. This is one of the ways in which we've implemented it. So let's consider a scenario now where we have a couple of sessions. And session number 1, you can see there a timeline down the left, says at 9 o'clock, I'm starting this long running query. Let's assume our employee table is huge. I'm looking for all the employees who are hired after 2004. And that query starts at 9 a.m. It's going to run for several minutes. At 9:03, a different session comes along and says, I want to make some changes to the employee table. In a lot of other databases, that would be blocked because we're not allowed to make changes while someone is actively reading the data. But in Oracle, we just let you go. We simply say, yep, you're allowed to do that. Let's say that session 2 says, I'm going to change the employee name from John to Sue. We've had a name change. And it turns out that that particular row is on block 3217. That session is allowed to make that change. Session 2 is allowed to commit it. He's actually changed and written block 3217 back to disk at 9:03. Of course, at 9:05, session 1 will eventually come across this same block, and it's been changed. And that's no good because session 1, as we know, if he starts the query at 9 o'clock, he needs the data as it was at 9 o'clock. So he needs block 3217 as it was before that change was made. And time in Oracle is effectively what we call the SCN. You can almost think of them as being synonymous. What is SCN? It stands for System Change Number. It's like a constantly increasing number that marks changes inside the Oracle database. You can almost think of it like a timestamp. So here's our data as it looks on disk in terms of the SCN. Block 3217, before any of this work started, had a value of John for the E name, and its SCN number was, say, 003. Session 2, the one that did the update, comes along and makes a change and commits that change. So the change is done, and what the change does is always increments the SCN number. So it's gone from 003 to 234 because there's been maybe 230 other changes on other tables throughout this database. And the employee name has been changed from John up to Sue. Of course, to do a transaction, as we saw, we always record undo. So block 3217 needs to record some undo as to how to undo that transaction. So how would we undo that update? We would take block 3217, we change the SCN back to 003 and change Sue back to John. That's what goes in the undo area. Session 1 comes along and says, I'm reading the employee table. I started a while ago. I'm reading the table. I need block 3217, and I need it as of when my query started, which might be SCN number 192. That session will encounter block 3217 on disk or in memory, and it'll say, yes, I have block 3217, but the SCN is 234 and the value is Sue. But the key thing is the SCN. The SCN is 234, which is higher than the block that requested at 192. That's too new. What the database do will take a copy of that block in memory, and then what it'll do is it'll go get the undo from the other session. It'll use the block 3217, which has the undo block address, and says, yep, go find the undo for that block, change the block from SCN 234 back to 003, change Sue back to John, and now I have a copy of that block as it was at a previous point in time. SCN 003 is less than SCN 192, and so we're done. That block is now valid to use for my query. So every query you do is actually a query at a point in time. And I stress that's a vast simplification. When you actually go look at the details of undo, there's incredible complexity going on there. We've sort of simplified this just to raise the concept of being able to undo transactions for the sake of giving query consistency. Every query you ever do in the Oracle database is locked at a point in time, that SCN being the time at which your query actually started. All FLASHBACK query does is let you choose a point in time that is not that of which the query actually normally started. FLASHBACK query lets you nominate the actual SCN at which you want your query to start. It doesn't have to be right now. This actually came in way back in version 9, believe it or not. FLASHBACK query is a technology that's been around for just coming up to almost 20 years. So I might do a query like this. Here's a normal query. We simply select star from the department table, and it might show that the current state of department name is unknown. Someone's changed them. All FLASHBACK query does is say you can nominate a point or SCN number in the past. So if I flip back, the current state of the department table is status unknown for department name. I say, let's go back to SCN 995401, and you can see what the data looked at a point in time in the past. This point in time being system change number 995401. Now, I don't know about you, but generally I don't have SCN numbers just stuck in my brain knowing what they are. You just can't just rattle them off. So if we're looking for something a little less geeky, we can do something which humans understand, which is we can nominate a point in time. Here's a similar query where I'm saying select star from department as of 20 minutes ago. This timestamp minus a 20-minute interval. So this is what FLASHBACK query is. Rather than a query starting at the point you hit the execute button, you nominate the point in time in which the data is to be queried at. To actually see what's going on here, to actually map SCNs to SMON, you may see on blogs out in the universe things like a reference to a table called SMON SCN time. If you see references to that, don't follow the instructions on there. This is an obsolete version of how we used to present the mapping between the SCN and the timestamp. You had to query that table. That's why you won't see it in the documentation anymore. It's just not present. We've actually improved it. It's obsolete totally, but you need to know about its existence. We might get to that later on today. The way you map SCNs to timestamps is now with two provided functions. We have a timestamp to SCN function. So for example, there I can see that this timestamp maps to this current SCN, or I can go the other way around. If someone gives me an SCN, I can work out what the timestamp is. And it shows me there, in this case, that SCN was 16th of September 2019. The last time I gave these demos was at OpenWorld, which is roughly about then. The granularity you have for that mapping is approximately 3 seconds. So for example, if I do a query here where I change the SCN number just backwards by 1 through time, you can see that I don't get an exact timestamp for every single SCN. The SCN maps to a granularity of 3 seconds. So I've got several consecutive SCNs there, but it says here they map to the exact same point in time. So if you're using a timestamp, you have a 3-second granularity. If you need to go more accurate than that, then you would need to dig down into SCN numbers to get precise moments in time that transaction data changed. But typically 3 seconds is going to be more than ample. The cool thing with FLASHBACK query is it's not something you have to use in isolation. You can use it in normal queries as if they were tables in their own right. For example, here, I can join the employee table as it is right now to the department table as it was on the 16th of September. So I can simply use as of queries anywhere I could use a normal query. I can simply do a flashback query anywhere. They could all be as of timestamp or as of SCN, or you can see there they can be some current data, some flashback data, etc. You can choose. At which point you're thinking, what's in it for me? Like, how often as a developer or a DBA do I want to see data as it was 5 minutes ago or 20 minutes ago? It's often we struggle to come up with use cases here. For me, as developers, one of the things I like the concept here is for unit testing. One of the classic things we often have to do in a unit test is look at the state of data now, and then run some logic, and then check the final state of the data and compare the two. That's what unit testing often is. I was meant to add 10% to someone's salary. What's the salary before? What's the salary after? When we're doing unit testing, to do this, often what we do is we have to write a lot of code to capture the state of the data before we did our unit test so we can compare it afterwards. With Flashback, we don't need that. For example, here, I can actually join the department table on line 6 to the department table as it was at a previous point in time. That's a perfect example of how I might want to do a compare of before and after for a unit test. I can do a full outer join, which would tell me which rows are inserted, which rows are deleted, etc. If there's rows now which weren't there before, that's an insert. If there's rows that were there before but they're no longer there now, that's a delete, etc. So rather with unit testing becoming complex where we have to capture the state of the tables before we do our unit test, we can now actually look at the state before the unit test after the unit test is run using a flashback query. So it makes our unit testing coding much, much easier. The other cool thing with using flashback data is, as I said, it's using the existing technology about undo transaction that we've had forever in the database. Well, back to version 4. Given that it's database-wide, the concept of transaction and undo, you could actually query not just your data back in time, you could query other people's data back in time, for example, like the data dictionary. We've all, well, I was about to say we've all done this. I've certainly done this in the past. We drop a routine that we didn't mean to drop. I've dropped the routine, or maybe I'm on the wrong database. How do I get that source code back? Hopefully it's in a source code control system, but if it's not, I can even query the data dictionary as of a point in time in the past. DBA source is just a view on top of various database dictionary tables. A drop of a procedure is actually just a delete from the data dictionary. So I could query DBA source as of 5 minutes ago and get my source code back. So flashback query is a great way of getting back information from the data dictionary if you're looking at information that you may have dropped. Anyone that uses Apex will notice also that you can, for example, export an Apex application as of a point in time in the past. If you've made some changes and want to abort them, you can actually export back to a point in time in the past. The other nice thing is you can use flashback query to do what I call functionality diagnosis. And let me explain by that by looking at some code examples. Let's say, as we saw before in the first example I gave, the current state of department name for this query is unknown, but I know 20 minutes ago, the department name was accounting. Now, does that mean that someone updated from unknown to accounting? Well, we can't really be sure because they may have done a single update. They may have done heaps of update. It may have been unknown, then something else, then someone may have deleted it, then reinserted it. A whole lot of stuff could go on just to go from unknown to accounting or from accounting to unknown. And the question is, can we use flashback query to work that out? And we actually can. We've extended flashback query to do what we call this thing called flashback row versions. With this new syntax, you can see on line 3, we can say select from department table, show me all the versions between a timestamp and another timestamp or an SCN number, etc. You can use that same syntax. So in this case, this is actually a single row. You can see on line 7, the department number is 10. That's a primary key lookup. I get 5 rows back because there were actually 5 transactions that occurred to this row between this timestamp and 20 minutes ago. So you can see I've got, it started off as accounting, then someone updated it to money grabbers, then someone updated it to finance, then someone upgraded it to bean counters, and then someone updated it to unknown. It was actually 1 row then and 5 versions of that row 5 transactions. You also get some cool functions when you use flashback row versions to get more metadata about those transactions. You get versions, start time, SCN, end time, etc. Let's look at those as an example. I've got the same query here, but I've added the 3 functions: versions start time, versions XID, versions operation. So not only do I get the 5 rows that shows the transactional history of that one row, I have the version start time when that row came into existence, when that transaction completed. Over at the far right, the 4 U's there are actually a U for update, I for insert, D for delete, U for update. So I know what kind of transaction it was. And also this thing called the versions XID, which we'll return to shortly. But you can see there I've almost got, what's the best way? Almost an audit trail of transactions to that one row on the department table using the flashback row versions query. You can get the lot, everything we know about that information, by using versions between SCN min value and max value. They're reserved keywords which simply say, whatever you can find in the undo table space, show me. And there we have, in this case, perhaps lots and lots and lots of version history for single rows in that table. Querying that might be expensive, because if you think about what we're doing is we're saying grab a row, go look at the undo information on it to go find a previous version of that row. So we go look at the undo. Oh yes, that's how I would roll back that transaction to get the previous row. If I ask for all the versions, I roll back that row, find the previous version. Then I get the undo from that one and roll back that one, get the undo from that one and roll back that one. I'm actually undoing potentially thousands or hundreds of thousands of transactions to try get the state of that row. So it could be a very expensive query, which is why by default, you don't get to run flashback queries in the database. You have to be granted that privilege. Your DBA must grant you the flashback privilege. It's a way of controlling who's going to potentially unleash those queries on the database. Rolling back, querying the department table from a couple of minutes ago, unlikely to be a drama. Querying the department table from perhaps 2 hours ago, where there might have been millions of transactions against the department table, could be very, very expensive. So obviously you use caution when you're using flashback query. As we saw before, you can mix and match these flashback queries with normal queries. But what if I want to actually run hundreds of queries that I already have, for example, as if they were 5 minutes in the past? You don't have to go through and edit every single one of those queries. You can actually just do DBMS flashback enable, and your session now is in flashback mode. So what happens now is normal queries like select star from emp, select star from demp, etc., will now all be flashback queries as of, in this case, sys timestamp -1 divided by 24, which is an hour ago. So you don't have to go edit all your queries to add as of an hour ago, as of an hour ago. You can actually set it at session level, and then all the queries you run from that point will actually be at flashback queries. A couple of things to note. If you are in flashback mode in a session, you obviously can't start a transaction. That makes sense. You can't insert rows as they were in the past. Similarly, if you're already in flashback mode, you can't actually change the flashback mode. You have to disable flashback mode in that session, and then you can change it to something else. So you can't just modify it on the fly. You go into flashback mode in your session, and then you come out of it and change it to whatever it wants. Just a couple of things there to be wary of. The big question, of course, that generally comes up at this point in time is how far? Like, yes, I can query 5 minutes ago. Can I query an hour ago? I mean, if I'm using the undo information to actually work out previous versions of the data, we don't keep that undo information forever. In fact, it really depends on the relationship you have with your DBA as a developer. Now, because I don't know the mix of developers on DBA on the call, I won't make a comment as to which one of these is the developer and which one of these is the DBA. You can decide upon that for yourselves. But it all comes down to this system parameter, undo retention. Now, what happens is at your database level, we have a parameter which is called undo retention. It defaults to 900 seconds. What that is how long that we will typically hold on to the undo information in your database for use for things like queries and flashback queries. So out of the box, it's typically 900 seconds, which is 15 minutes. Now, let me put a slight caveat on that. Hence, I'll put a little tilde there. Undo retention is not a guarantee It is a rough guidance that the database will try to hold information for that long. It is governed by other things such as how big your undo table space is, etc. But what we do is we endeavor to keep to around about 900 seconds based on this parameter. Having said that, let me now augment that information by the fact that at Oracle, as I said, why do work that we don't have to do? If your undo retention is set to 15 minutes, but your undo table space is huge, we are not going to aggressively go clean out information that's more than 15 minutes old just for the sake of cleaning it out. Why would we bother? If it's there and it's not causing problems, we may as well just leave it there. That's more efficient. So even though your undo retention might be set to 15 minutes, typically we see undo retentions much longer because people have large undo table spaces. How do you know what your real undo retention is? You can go look at $undo stat. It's an interval based, it takes snapshots of regular intervals. It shows you what the undo retention you can actually expect for that interval is. And typically you'll find it's much, much larger because people have lots of free space in their undo table space. If you are consuming huge amounts of undo and your undo table space is filling up and is small, then you won't get 15 minutes. It could be far less. But the tuned undo retention is probably the much more accurate version of actually what you're really getting as opposed to the undo retention parameter. If you are very, very focused on, I must get that undo retention, when you create your undo table space, you can actually nominate whether the retention is guaranteed or no guaranteed. Guaranteed means if the undo retention is not being met, we will grow the table space. And if we can't grow the table space, we will give people errors when they try to allocate undo. In that way, we're saying we will guarantee that we will meet your undo retention requirements. By default, it's no guarantee, which means we will release undo information rather than grow the undo table space. And we will try and meet the undo retention, but we're not going to guarantee it. But you can choose. But generally, it's undo retention, then $undo stat tuned undo retention. And if you're very critically focused on that undo information being available, then you look at changing your undo table space definitions. If you want to go back further than that, typically, no matter what kind of database you got, you're not going to hold your undo for more than an hour or maybe 2 or 3 hours. If you want to go back further, like we're talking days, months, years, then we use a different technology, which we will get to. A couple of things to be aware of. Generally, we don't allow you to span DDL. So if I look at the department table as it was an hour ago, but 10 minutes ago, I added some columns or dropped some columns or I truncated the table, then we're going to have some dramas. And key thing is what we're doing is we're rewinding data. That's the key thing here. We're not rewinding things like character sets or NLS changes, whatever. If your session is set to a particular time zone, for example, and you query the data as it was 5 minutes ago when your time zone wasn't set to that, then we don't change your session details. We're only rewinding data from the table that you're querying. So that's flashback query. We've ticked off number 1. We've only got 5 to go. How am I going for time? Really badly. Not to worry, we'll charge on. Some of them we get a lot faster, we hope. Flashback transaction. On our flashback query, our flashback row versions query, we had this column called the versions XID. Now, what does XID stand for? It's shorthand for transaction ID. And if you're a DBA on this webinar, you've probably looked at $V transaction in the past and seen 3 columns called XID, USN, slot, and SQN. That stands for undo segment number, slot number, and a sequence number. And in fact, the transaction ID, that strange hex string we saw in our flashback row versions, is actually the same thing, just in a different format. If I query $V transaction, I'll get, for example, for an active transaction, slot undo segment 1, slot number 31, sequence 674. If I go look at the versions XID, it's actually the same information, just in a single hex field. The 01 is the segment number, the 001F is the slot number, and take my word for it, A202 is 674 in hex. So the version XID is actually the same as the entrance in $V transaction. They are one and the same. It's the transaction identifier. The actual concept of a transaction ID is actually a reference to the undo segment. So if you want to think about what a transaction ID is, actually in Oracle, a transaction is your ability to get some space in the undo segment. That's what a transaction is. It's actually a pointer to the undo information, not a pointer to anything else. It actually is the undo information entry point that actually defines what a transaction ID is. Because as we saw, that flashback is the ability to take a transaction and rewind it for the purpose of query, well, maybe we could use that to actually undo data changes as well. So Oracle gave us this view called flashback transaction query. If you know the transaction ID, one of the columns we give you is the undo SQL. If I've inserted a department row, and that's a transaction, then in order to rewind that to do a flashback transaction query, logically speaking, I'm doing a delete. And so what we can do is we can synthesize an undo SQL statement based on the undo information, the instructions we saw earlier on today. So for example, if I do update the department table, set department name equals finance, where department equals 10, I can go get the transaction ID from my flashback versions query, which is that big long hack string. I can plug it into flashback transaction query, the database view, and it gives me what the undo SQL would be. It says you updated the department name to finance. To undo that, I would update the department name back to bean counters for this particular row ID. It doesn't know about primary keys and stuff like that. It's simply using the undo information to say, this is how I would reverse out that transaction. Go to that row number, change the department name to bean counters, and we're done. So flashback transaction query lets us dive into the undo segment to actually see how to undo in a SQL representation a transaction we've just done, even though it's committed. Now you need to be careful if you're ever querying flashback transaction query. As I said, you can see from its definition, it is a direct memory structure. It's actually a pointer into this thing called $K2UQQRY. And we can sort of assume that's undo, undo segments, query, etc. You never ever query it without predicates. So you always must provide a transaction ID. And you should always use hex to raw because the transaction ID is actually a raw column. So always put hex to raw around your XID string. If you forget either of those two things, rest assured, you're going to smoke your server. Its CPU is going to go through the roof. As I said, flashback transaction query is a memory structure representing all the complexities of your undo segments. If you just do flashback transaction query, transaction ID equals hex to raw, even though it's a memory structure, you can see the explain plan says we're using some sort of virtual index structure to get directly into the right memory structures. If we don't, if we forget hex to raw, we get a full access across that structure, even though I've given it a predicate. And you don't want to be churning through every piece of undo information in your entire database. That's going to take a long time to run. And because it's accessing memory, it's going to be actually burning a lot of CPU to do it. So be careful querying this. But that column called undo SQL, it suggests that we could actually roll back a transaction that was already committed. And that's what flashback transaction is. So what's in it for me? We've spoken about what's in it for flashback query. What's in it for why would you want to flashback a transaction? The first one obviously is, as we said at the start of the session, is if you have an accident. You make a mess, you go, oh no, I've deleted a row I shouldn't have, I want to undo that. And to explain what I mean by that, the three worst words that you can have as a developer generally is delete, followed by commit, and then uh-oh. They're the three words that strike dread into every developer's heart. It's a lonely, lonely place when you're sitting at a system and you've deleted something in production, and the moment you hit commit, you know that, oh no, there's no way back. There's no rollback, there's no nothing. Rest assured, flashback transaction is here to help. And it's funny how whenever you delete a row in a table, it's funny how even if we've deleted all the rows in a table, you know you've committed it, you know the rows are gone, you'll still log on and do a select count star, praying that there's some rows left. You know they're gone, but it's funny how we still do this. But to undo a transaction that's been committed, we need some technology here. So let's look at how we do it with flashback transaction. I've deleted the department row for department 10. I've committed that delete. There's no rollback option here. First thing I do is I use a flashback row versions query to find out the transaction ID for that delete statement, because I need that to know what transaction I want to roll back. And this is how we use flashback transaction. I use DBAs flashback transaction backout. I'm undoing one transaction and I pass in an array of those transactions. And this is the one that from that previous slide. And here's the slightly disappointing thing. The first time you run this, after you've deleted that data and you know that, oh no, I'm going to lose my job. Okay, I've stumbled across flashback transaction. This is what's going to see. This is what you're going to see. This is a very sad moment in your life because at this point, you get to wave goodbye to your data. It's gone forever. Because tucked away in the flashback manual is this. You only get to use flashback transaction if your database has supplemental logging turned on. So if you're ever planning to use flashback transaction at some stage in the future, this is what you need to do. It is not a case of you get to turn this on now and now I can go back and fix up that department row I deleted. It's from this point onwards, I can use flashback transaction. So be aware, supplemental logging is a requirement for flashback transaction. So let's redo our demo now that we've turned on flashback transaction or supplemental logging. I delete the row, I commit the row, I find my transaction ID, I start my transaction back out. This time it says, I'm done. Fantastic. But notice, I didn't get an error, but I was trying to get department 10 back and it's still not back. You might be thinking, has something gone wrong? Don't panic. This is actually a really cool piece of tech. I thought we actually did this pretty well. Because a single transaction could have huge ramifications. This is a trivial one. I deleted one row. But what if I deleted one row from department, 20 rows from employee, did a location table, I did a whole stack of other stuff? That could be one transaction. And I might not know what the implications are. So what we do is, when you flashback a transaction, we create a brand new transaction called a compensating transaction. And we see that from DBA flashback transaction state. What's the compensating transaction? We have that ID. I can then get what's called a transaction report. What will this compensating transaction do? And it comes back in a big lengthy XML file, but it shows you that for this one, I'm just going to reinsert the department 10. So I like this. It's like a two-stage process. Yes, I want to undo a transaction. I'm going to do that work, but let you know what's going to happen. In this case, it's just an insert. I can review this. Yes, I'm happy with that. Once I'm happy, I issue a commit, and then my row comes back. I like this because I have this choice now. I can actually commit or roll back. And that's very, very useful because you never really know what might be in a single transaction. So that's flashback transaction. So that's solving accidents. The second thing obviously is, once again, unit tests. Back in the day when I first started coding, unit testing was easy because we all used client server or 3GL programs. So what you would do is you would do a whole lot of DML on the database. You wouldn't commit it, run your unit tests, and then issue a rollback. Nowadays, the thing that's actually doing a unit test, could be calling 25 different services. We got microservices and all this kind of stuff. So the concept of doing a DML and then being able to roll it back trivially is almost a thing of the past nowadays, because you call one service to do a transaction, you call a different service to add to that transaction, then another service, somewhere in there a commit takes place. And at the end of all that stuff, you now have to go examine the data to actually see if your unit test worked. The way developers do that is they're petrified about changing data on the database, so they often write mockups up in XML or JSON, whatever. That's a pain because it's not a true test of your system. With this thing, you can actually run your unit tests and happily commit them. As long as you record your transaction IDs, at the end of your unit test, you can actually flashback that transaction to roll the database state back to where it was before your unit test. So really cool. So you run your test, capture the transaction ID, and when you're done, flashback the transaction, and your unit test has undone all the changes it's made, even if it did lots of commits and lots of changes through different services. So it's cool. Commit, validate, undo the transaction. Number 2 finished. Let's get on to flashback drop. As I said, these are the 3 worst words for developers: delete, commit, and uh-oh. And for that, you use flashback transaction. For DBAs, it's not 3 words. For DBAs, it's 2 words. And those 2 words are drop, followed by uh-oh. And what happens there is, whenever you do a drop and then an uh-oh as a DBA, the first thing you do, well, this is the first thing I normally do, is you fire up LinkedIn and you look for what DBA jobs are going, because you're about to lose yours. But once, if there's nothing on LinkedIn for you, you have to see if you can salvage this issue. And this is the worst place you can be as a DBA. I've described the employee table and it's gone, especially if that's a production system. Way back in Oracle 9, I was on the Oracle 9 beta program back in sort of year 2000. The syntax for getting undoing a drop table was literally undrop. In the beta, it was undrop table, which I thought was really cool. But obviously, the marketing people probably got a hold of it. They said that's not cool enough. So this is what flashback drop is. You do flashback table to before drop. If you've ever used a PC or a Mac, you're familiar with the recycle bin concept. You delete a file. We don't really delete it. What we do is we give it a special name, we hide it from view, and we simply keep it. And as your machine gets full up, you might get a prompt saying, do you want to empty your recycle bin because it's starting to clog up a lot of space? It's exactly the same here in the Oracle database. When you drop a table, all we do is silently rename the table to a special name and such that you don't see it anymore. We don't drop the data. That's what a drop does, unless it's been explicitly turned off by your DBA. Where do we see our recycle bin like we would on a PC? We simply go to user recycle bin. If we look at it, you can see I've dropped the employee table. The database also dropped the primary key index, primary key emp, and you can see the names it's actually given them. They all start with bin dollar and some cryptic name. So all we've done is, in fact, if you ever look at deleted files on a PC, typically the first file, the first character becomes a question mark. It's the same thing here. Our first prefix is bin dollar. And so we've renamed the table, set a flag and saying it's hidden from view, but it's still there. If you want to do it in SQL+, you can simply do show recycle bin and we query that same database view. When you drop a table, all the subordinate objects will be renamed as well. So you drop the emp table, if there was an index on the emp or a constraint or triggers, they all get renamed as well. How do I get it back? We simply use this syntax, flashback table employee to before drop, and it comes back. If you've reused that name, maybe I dropped the employee table and created a new one, but I want to get the old one back. I can do flashback table emp to before drop and rename it. So I have a copy of it without overriding the existing one. Key thing here is the indexes and constraints and triggers will not be renamed back. They come back into existence, but they will still have their bin dollar name. It's your job to then go decide what to rename. We do that to increase the chances of it actually being successful, the flashback, because if we had to go look at all the subordinate objects as well, and one of them had been reused, then the whole thing would have to be aborted. Now the question is, how long? If I drop the employee table right now, can I get it back? What if I dropped it yesterday? Can I get it back? It's a bit like your PC metaphor. And so I say it's this, it's the how long is a piece of string concept. On your PC, put a file in a recycle bin, I can come back to it tomorrow. As my PC fills up, Windows pops up and says, you should empty your recycle bin because you're running out of space. We do the same thing on the database, but we do it automatically, which means if you have a lot of free space in your table space, then we will simply hold on to those dropped objects. If someone has purged the recycle bin using any of these spans, then it obviously might be gone as well. But even if nothing has been purged, if your table space is starting to fill up and you create new objects or you allocate more space for existing objects, then we will silently ditch things out of the recycle bin rather than give you a full table space error, and rather than auto extend as well. So what will happen is if your table spaces have heaps of free space, there'll be stuff in there forever for the recycle bin. If your table spaces are really full, things won't last long in the recycle bin. So be aware that it's really a question of how much free space you have. These are examples of how to purge the recycle bin. You can purge the recycle bin for a schema. That's the first one. Purge DBA recycle bin is everything for the whole database or pluggable. You can nominate tables, table spaces, etc., etc. So you have plenty of flexibility there. I can't stress enough, dropping a table is less dangerous than truncating a table. If you drop a table, we can undrop it with flashback to before drop. If you truncate a table, that data is gone. There is no untruncate option in any version of Oracle as of today. So be aware that truncate is actually probably the most dangerous thing you can do in a database as opposed to drop. We've covered 3. Flashback table, number 4. How are we going for time? Still badly. Oh, man. Oh, we may run a bit over. We'll see how we go. So we've covered flashback drop. That's the top left one. We've covered flashback transaction, a single transaction. What about if you make a mess of a table? You've done 30, 40, 50 transactions that have just messed up a table. That's what flashback table is for. And it's a fairly similar syntax. Simply take a table back to a particular point in time. It's not undrop, that's flashback to before drop. If you drop the table, flashback before drop. This is purely you've made a mess of the data. Now, what's in it for us? Once again, it's great for repeatable tests. I want to do some testing against a table. I've made lots and lots of changes over lots of different service calls. Now I just want to rewind the entire table back to a certain point of time. I don't need to write explicit cleanup scripts. I can simply flash it back. Do your test, do your commits, lots of commits, flash back, your table's back to how it was before. It's a busy operation. What we do is when you flash back to 10 minutes ago, for example, we delete all the rows from the table that have been modified since that 10 minutes period, and then we reinsert fresh ones to reflect how the table was. So it's a busy operation. You can actually even have triggers fire. If you have triggers in that table that might do auditing, for example, you can have those triggers fire if you want to actually capture what's going on. Obviously, the row IDs will change. If you're deleting rows and reinserting them, they'll get fresh row IDs, so be aware of that. Because the row IDs change, you have to enable row movement on the table. If you've got indexes, if you created an index and you flash back the table, the index stays. As I said, it's just the data we're flashing back. We're not changing the structure. It is a single transaction, but you can do multiple tables. You could actually do flashback, employee and department, etc. Anything involved in flashback table will be locked during the whole flashback operation. And at the end of it, because we're just changing data, all the normal stuff must be valid. Your primary keys, your foreign keys, all must be valid at the end of the operation. It's really just automating what you would have to do manually, a manual set of deletes and inserts and updates to clean up the mess. So at the end of it, all the normal rules still apply. Similarly, the stats will be unchanged. So if you inserted 1,000,000 rows and you flash back those 1,000,000 rows, you might want to regather stats to reflect accurate stats. What will happen is while this is going on, you'll see the presence of a table called systemp_fbt, flashback table. It's effectively a staging area where we hold your information from your current table to create an old version of that table. So be aware of that. It might hang around after your flashback. You can drop it once it's finished. Most DDL is going to be a time boundary. So obviously, if you truncate the table 10 minutes ago, you can't flash back before that. If you dropped a column 5 minutes ago, you won't be able to flash back a table through that DDL. You get this error, unable to read data, table definition has changed. Each release, we've got a bit better with that. So for example, you might add a column to a table and then flash it back. We will allow the flashback to occur, but at the end of it, that column is still there, that new column, because as I said, it's just the data that we're flashing back. If you're in the middle of a transaction, you can't do a flashback, you must end the transaction, which leads us on to our, what are we, fifth one, flashback database, I think. How are we going for time? We're going to run over, I think. We'll chug on. Hopefully you can stay on the call a bit longer. So as I said, we've covered flashback drop. We've covered flashback transaction. We've covered flashback table. What if you just make a mess of your entire database? And let's face it, sometimes we do that. That's where this fifth technology comes in. This one generally is more for your database administrators. If you want to be able to flash back an entire database to any point in time, you need to do this, alter database flashback on. What does it do? In any database, we have a couple of things going on all the time. The database writer is writing changed blocks to disk. The redo writer, LGWR, is writing redo to disk, changes to disk. So you have new blocks to disk and redo. The combination of those lets you roll forward a database. When you turn on flashback logging on a database, we have a brand new process that writes effectively old blocks to disk. New blocks database writer, redo all the intermittent changes, and old blocks get with the flashback database writer. With that information, you can now take an entire database back to a point in time, as long as you have flashback logging turned on. That's pretty cool. If you don't know a time, or if you want to nominate times and give them meaningful names, you can actually nominate a thing called a restore point. I can say, it's 2 o'clock in the afternoon. I'm going to create a store point called OK. I'm OK so far. I might be doing an application deployment. I can then flash back to that point. I don't need to know the exact time. As long as I know the name, I can flash back the database to that point, and it will rewind all the changes made to that point. It's not like a restore from backup. It rewinds changes back to that point in time. So what does it cost? There actually is a $V view called $V flashback database stat, which for a given time range will show how much flashback logging is being created, and you can compare it to the amount of redo data. And it's all about the amount of blocks we capture with flashback. So let's say I update the employee table, which is tiny. It's a 1 block table, 28,000 times. You can see I used 9.5 megabytes of redo to do lots and lots of updates, but almost a third of that for flashback logging. So flashback logging tries to be nice and efficient. It's only about changed blocks, really. I've only changed 1 block here lots and lots of times, so I can actually take just copies of that block, not for every single change, just for certain amounts of changes, and we'll see how it manages to sort out the mess later on. If I update a huge table with lots and lots of different blocks, I've done the exact same amount of work, 28,000 one-row updates. I've still got 9 megabytes of redo, but now because I've changed so many different blocks, I get a lot more flashback data as well. So if you're looking for a sort of a rule of thumb, you can sort of assume your flashback logging will probably be about somewhere between half as much again as the amount of redo. If you're doing 10 gig of redo a day, you'll probably do 5 gig of flashback logging as well. That's the price you pay to be able to flashback a database. A reasonable compromise is what we call guaranteed restore points. You don't have to have flashback logging on turn for this. When you create a guaranteed restore point, all we're doing is saying, make sure I can get back to this point in time. You're not getting a guarantee you can flash back to any point in time, just to the point nominated by this restore point. In that case, you don't have to have flashback logging turned on. The database will just capture enough flashback logs to actually go to this point in time. Flashback logging is started as needed. So what's in it for me? As a DBA, this is awesome. Safe for deployment. Let's say you're deploying an application. At 9 o'clock, I start doing all those DMLs and DDLs that are required. I'm changing hundreds of objects. At 9:40, the whole deployment goes terribly wrong. The proverbial hits the fan, as we say. What do? I just run flashback database to 9 o'clock, and all those changes are rewound for me, and it's remarkably quick. It's pretty cool. Obviously, repeatable end-to-end testing. If I'm doing a whole system integration test, I can let the developers go and testers go absolutely nuts, changing everything, because I know I can get the whole database back to the start of the test with flashback database. The other cool thing is with pluggable database technology now, you can actually give every single developer their own pluggable database, because you can have up to 3 pluggable databases for free in 19C, and every developer can have Express Edition on their PC for free. And you can actually do flashback pluggable database as well. So people can actually do that as well, which is pretty cool. Just moving a window out of the way here. The other cool thing is, because of that, you can now give production data to developers, which is pretty cool. Because now you can take a pluggable from production, give it to developers. Flashback database is so cool, there's actually a secret flashback database, which is if you've ever used a standby database where it's in recovery mode, you may have seen this technology where you can convert a standby to what we call a snapshot standby. It opens the database read-write, and you can do whatever you want. And at the end of that, you can say convert to physical. What's going on behind the scenes is we create a restore point, turn on flashback logging, and when you say revert to physical, we simply flashback the standby to that point in time and then allow it to proceed. So we actually use our own flashback database technology to make your standby databases more productive for your use. You do need to be careful with your archive logs because, as I said, we don't capture a lot of flashback logs. If we can, we try to actually keep the amount of flashback logging as low as possible. So if you don't keep your archive logs, sometimes you'll encounter this. I want to flashback to a point in time and it says I don't have the redo logs. And you might be thinking, well, hold on. I've got flashback logging turned on. Why do I need redo logs? This is what happens. If I'm doing a lot of operations in my database, at regular intervals, I'm going to capture flashback logs. I'm not going to capture logs for every single change. That's a huge amount of I/O I would have to do. It's like doubling up on the redo. So when I say flashback to 932, what if 932 is here? It's not right at the point where I captured an image of the employee table in my flashback logs. what we do is we go back to the nearest flashback log that's before 932. This might be at 930. And then we use the redo to roll that block forward like we normally do database recovery. And to do that, we need the archive logs. So to flashback a database, we generally jump a bit further and then roll forward slightly. Remember that you need the flashback logs and a little bit of redo to bring you to a particular point in time. Generally, my rule of thumb is if I've got 30 minutes of archives, I'm generally going to be okay. That's generally my rule of thumb. So be aware, don't go deleting your archives around your flashback logs. You need them both. Okay, it's actually now an hour. So I'm going to put this out on the chat line. You can put your little votes on the chat line. We can charge on and do flashback data archive, or we can jump to the end. So this is your chance to vote in the chat. We either continue on for about 10 more minutes, or we jump to the end and do our quiz and stuff. So this is it, your chance. Jump on the chat now. We've got one continue. It's looking promising. Cool, good. We're going to charge on. Let's face it, if you're like me, you're probably stuck at home. There's nothing more to do anyway. So let's charge on. We'll do the sixth one, and then we'll get to our competition. Flashback data archive, our last technology. This is less about flashback, more about archiving. The first thing we do is we need a table space. You can use an existing one, but you need a table space to store this information. This is the new object we create. We create a thing called a flashback archive. We give it a name. It's just a logical name. We nominate a table space, and then this is the interesting thing. We nominate what's called a retention. And the retention says that anything I put into this flashback archive, I'll be able to do a flashback query as far back as that retention. So not just as much as my under retention. If I put an object into this flashback archive, I'll be able to query it as it was up to a year ago. So I put my table into take my employee table, I put it into the flashback archive. I do lots of DML on it. I do it for days and days and days. If I do select star from the employee table, I just query the employee table. That makes sense. If I say select from as an hour ago, that's probably in the undo. That's just a normal flashback query. I don't need any special technology to do that. But what if I wait 3 days and say, show me the employee table as it was 3 days ago? Suddenly we see some changes in the execution plan. Something's obviously going on here. This is what flashback data archive is. When you put a table into a flashback data archive, we create some extra objects to store information that lets you do a flashback query as far back as the retention. If I go query user tables, you can see that I got the employee table. You need to take my word for it. It's object 71036 in user objects. And we have these information, other tables that created for us. FBA HIST, FBA TCRV, FBA DDL colmap. If we look at the DDL, we can sort of get a rough idea as to what's going on here. The FBA TCRV, I'm guessing TC maybe stands for transaction control revisions. I'm just guessing. We have a start SCN and an SCN and start and ending SCN. So we got a range of system change numbers. We got an XID, a transaction ID, and an operation. So it's probably a catalog of all the transactions and operations that have occurred on the employee table. FBA HIST, the DDL for that, has the same information, start SCN, end SCN, a transaction ID, plus all the columns of the table. So it's probably a child of the other table. So we can take some guesses as to what's going on here. We're storing every single transaction and all the row information for those transactions in this table as well. Key things to note, because we're storing these, your own tables shouldn't have these columns in them, because if we go back to here, obviously we would have a clash if your table had a column called operation and we want to store a table called operation. So be aware that these columns here are no-goes. Don't use these in your tables if you want to use them in a flashback data archive. What's in it for me? Whenever I present about flashback data archive, people say, seriously? Like, why would I want to see what the table looked like last June? Well, let's talk about something related to looking at data historically. If I want to query the table as of last June or March or 2 p.m. Wednesday, what I'm really saying is I want to be able to see every historical version of every single row. That's the capability it gives me. That sounds pretty familiar. That's what we call audit history. And we've all done that. I would say almost everyone that's ever been a developer on a call has done this kind of thing. You've got a table called T, and the first thing we have to do is create a table called T audit, which has some extra information. And then what do? We throw a trigger on our table called T, which is every time we insert, update, or delete, we copy the information into our audit table. Now that works fine, and most of us do it, but it's slow because every time you do a big insert or a big update or a big delete, you have to fire that trigger, and then you've got a lot of stuff going on. You can see there in this trace data, I'm doing 1,000 inserts into my audit table. It fires for every single row. It's expensive to do triggers on tables with lots of transactions. Flashback Data Archive gives you a better version because Flashback Data Archive is the ability to query every single version of the row. So I can go back to my Flashback row versions query and actually you can see here every single version of every single row. And I can use the things like version start time, version operation to get all that audit history. It's very cool. Now, as I said, this has been around since version 9. So why didn't we use Flashback Data Archive to replace all our auditing? After all, it's been there for 20 years. The first reason is on our audit tables, we typically want to have more information than just the table columns. We want to have who did it, when, how, what machine they're on, etc. And we didn't want to have to add all those columns to our base application tables just because we wanted to use Flashback Data Archives. And the second reason was a bit more graphic, which was we used to charge for it. Flashback Data Archive used to be a separately licensed option. And that obviously can cause some pain for people. As long as you're on 12C, things are a lot better. You can use the context extension with 12C, which says simply, I can do set context level of all. And now when I do a transaction on the employee table, which has no additional columns, with the transaction ID that comes from our Flashback Data Archive tables, I can actually get more information. It's captured along with the transaction. Using DBMS Flashback Archive get system context, I can get the fact that it was done by Scott on this laptop using SQL Plus, etc. There's a few other things as well. This is all the stuff that we can capture. Hopefully that motion path came out along your YouTube video okay. But yeah, huge amounts of information we capture. We can also join to a dictionary view called Sys FBA Context Audit, which actually has all that information for each transaction ID. So now I can join my employee table with Flashback Row Versions query, get the versions XID column from Flashback Row Versions query, join into Sys FBA Context Audit to get the context information, the who, the when, the machine, etc. So it's like my full audit information, but without having to have triggers. It's very, very cool. Okay, let's wrap up because I'm taking a lot of your time. There's a few more slides, but they're really just idiosyncrasies around Flashback Data Archive. But let's wrap it up. We've covered 6, what I think are incredible technologies that are very mature now. They've been around for 20 years nearly. Query, table, drop, database, transaction, archive. But the key thing is they're not just for accidents. I think the key thing is the opportunities to actually streamline your modern development are now really, really huge. And they're all included for no extra cost in Enterprise Edition. They're not separately licensed anymore. They're all basically available to you in Enterprise Edition. Very, very cool. Now then, before we finish off, as I promised, you get to win stuff. If you've endured me talking and talking and talking for 70 minutes, let's see how your flashback knowledge goes. So let me do a new share here and see if we can get this to work. First, so this is what you need to do. You need to go to menti.com in your browser, and you'll be asked for a code 599520. Please put in your full name because we're going to need that name to actually have the winner here. So you need to go to menti.com, code 599520. Now I need to wait for 30 seconds because there's a 30-second delay on the YouTube people who probably want to be able to see this. So you go to menti.com, type in that code. Now I can see people joining, which is fine. That's cool. Now I'm going to start in 10 seconds because it'll be a quiz. And the way this works is you'll be asked a question with multiple choice, and then you get to answer. Obviously, you have to answer correctly, and you have to answer quickly. And that's how we work it. And you'll have a time limit. So that's how it works. Okay, I can see 60 people on. I got 65 people on. This is awesome. We got people absolutely smashing it in here. This is very cool. Okay, the number's still going up, so I will leave it a little bit longer and see how we go. 80, 81, everyone's keen. That's awesome. Very, very cool. Okay, we're going to start the quiz. Hopefully you're all ready and signed on. Well, the numbers, we've bumped up. Okay, we're up to 100 now. People still going up. People are keen. Okay, here we go. We're starting the quiz. Which of these is not a flashback technology? Three, two, one. Time's up. Okay. Oh, look at this. Awesome. Very well done. The vast majority of people got it right. Okay. So next question. There are 4 questions in total. You have to be the winner at the end. For flashback table to work, you must do what? People are rapidly voting. 3, 2. Okay. You must enable row movement. Supplemental logging is for flashback transaction. Okay. Question 3. Let's move on. To flashback to a guaranteed restore point, you need archive logs, flashback logs, archive log and flash logs. Neither, because it's guaranteed. Boom, well done. And we're on to our final question. Here it comes. Under retention is set to 900 seconds. That's the default. That means you can flashback query as far as up to 15 minutes. Guaranteed 15 minutes or neither, could be more or less. Here we go. Okay, we've got all our answers in. Now I think it's going to give me a leaderboard. Okay, let me share that screen. There's our leaderboard. Amit Mittal, 3,404 points. Well done. You are our winner. Sai will be in touch with you. I think you're getting an Amazon voucher. So there we go. Well done, Amit. You've done very, very well. And please, if you get a chance, throw on the chat line or feedback to the All India user group. Did that quiz work easy for you? Does it work? The first time I've ever used this menti.com, it seemed pretty cool to me. An easy way to do quizzes, and it seems a fairly fair way to do quizzes as well. So if it's your first time you've seen that, it's the first time I've seen that. I hope you enjoyed it. And once again, well done to Amit. So that was our quiz. Okay, we are just about done. Thank you very much for your time. As I said, please reach out to me on Twitter. There's my Twitter handle, Connor_MC_D. And I'll finish off with one last slide, which is this one. Huge shout out to Sai and the user group. We're doing our best to get you as much content while we're in this virtual world. So next month, it'll be compression, 15th of April at 8 p.m. Mark your calendars on that. And I just want to say thank you very much. Obviously, I haven't been in the chat line for the thing, but I'll go through all the chat and things I can find there that we didn't cover today. I'll do a blog post on so we can hopefully cover off all your questions. The chat is saved and etc. But yeah, thank you very much for your time. And I'll hand it back to Sai.
Thanks. Many thanks, Gunnar. I think 60 minutes is not enough anyway. So thanks for joining. Many people joined from YouTube Live, actually, more than Zoom. So we have like around 12 questions. I think since we are running out of time, so we will answer all these questions in same YouTube channel in the description window. Okay. Thanks a lot and see you on 15th of April, 8 p.m. IST for the next speaker. Thanks a lot. Stay
Thanks,
safe. Bye.
everyone. See you all soon.
Thank you. Bye.